Okay, so what we're going to be using this video for is to just do a quick overview of how to read the periodic table. This is just a neat representation of the table and the actual elements that make it up. And so in here you'll see things like pictures of liquid mercury and actual zinc weights and things like that. You'll also see some pictures of the people who either discovered or made an element, or who the element is named after. And so those are there. Now, when we use the periodic that looks a little more like this, and this is really targeted at providing you with the important information that you are going to utilize when reading a table to make conclusions about the elements. And so this table has been organized such that it groups the elements into periods and groups, and they're placed that way such that elements are found near other elements that share their chemical characteristics. And so that works when you go down the table. So elements in the same, what you would think of as a column, typically behave similarly. And so what that table can do for us is it can tell us about the number of protons, neutrons, and electrons that are found in a given element. The way that we figure that out, so those are the subatomic particles. The way that we figure that out is we need. And so on this slide, what you'll see is how to access the information that is contained within that periodic table. So on that periodic table, every element has its own box. And within that box, there are really three key pieces of information for each element. So the way that you'll identify it is by the symbol or the name of the element, always found sort of centered in the middle of the table. And then the other two very important pieces of information for each element are the atomic number. Okay, this is number one. This is always found in the top, sometimes at the left, sometimes at the right, sometimes centered of each element. And this lists or tells you the number of protons found in the nucleus of that element. The other one then is the atomic mass. Okay, atomic mass is always found towards the bottom of the table. The atomic mass is the actual mass of an element. That's in the units AMUs, which are units that you won't use anywhere else. It stands for atomic mass unit. And those numbers, that represents the number of protons plus the number of neutrons in an element. And one important thing about the atomic mass is that we, when we're calculating neutrons, we're always going to average or round the mass. And so if it's 13.9, you're going to round that to 14. And if it's 13.2, you're going to round that to 13. When we look at the next slide, we can get some information here. So the number of protons is very simply the atomic number. That's the number that's found up in the top of each element. And so that's basically representative of the number of protons found in the nucleus. And that is actually the defining characteristic. So the difference between one element and another is all about the number of protons. The neutrons and the electrons aren't so important when determining an element. In order to find the number of neutrons, what we do is we take the atomic mass. Okay, so the atomic mass, remember, is at the bottom, and we subtract from it the atomic number, which is that number at the top. And that will give us the number of neutrons found in the nucleus of a given element. Now, there's one step there that we have to do, and that is we take the atomic mass, which is that number at the bottom, and we round it to the nearest whole number, And so 13.9 becomes 14, and 13.1 becomes 13. So I'd like to try a little practice, and so we're gonna do some of this with the element sulfur. So the information for sulfur is pictured here. For the number of protons, remember this is the atomic number, which is found up here at the top. And so you very simply just transfer over. That's 16 protons per atom of sulfur. For number of neutrons, you remember that we have to do the atomic mass, that's here, minus the atomic number, that's this one up here. Okay, and so for this element we get 32. Now we're rounding it to 32 because 32.065 rounds to 32. So we get 32 minus 16 gives us 16. And that's the number of neutrons. Okay, our last one is the number of electrons. And the number of electrons is just equal to the number of protons. Okay, that's because electrons have minuses. Electrons have minuses and protons have pluses. And you have to have your pluses equal your minuses. So in this case, that's the atomic number. So that's 16, the number of protons. So what I'd like you to do is I'd like you to take a look at fluorine here, and I'd like you to work out the number of protons, neutrons, and electrons for yourself. Go ahead and pause the video, and then I'll work through it. All right, so what you should have found for your protons is the atomic number 9 protons. What you should have found for your neutrons is the mass, so that's 18.9. We're going to round that to 19 for the atomic mass, minus the atomic number, which is 9. So you should get 10 neutrons. And then electrons, remember electrons equal protons, so that's going to be 9. So 9 protons, 10 neutrons, and 9 electrons. Okay, go ahead and take a look at radon also. And take a minute, pause the video, go ahead and do your own math again. So for radon's a much heavier element. It'd be found much lower down on the table. For protons, though, that's still just the atomic number, so 86 protons. For neutrons, we need to subtract the atomic number from the atomic mass. So the atomic mass, 222, minus the atomic number, 86. It's going to give us 136 neutrons. So you'll notice that that's not even, but that's okay. What has to be even is the electrons, the negative charges, with the protons, the positive charges. And so here for electrons, we'll have 86 electrons.